Okay, one thing I want to mention before we start the video is if you guys are interested in being a part of the Founders Series, which is going to be either 10 or 20 of these bracelets that I'm going to make. It's going to be the first batch. I'm going to sell them to 10 or 20 people, and what I've been thinking would be cool is have them get sold, send them out to these 10 or 20 people, and then I want to do a 15 to 30 minute Zoom call with every single one of you guys that buy one of the Founders Series, and I want your guys' feedback. I want to see what you like, what you don't like, and I'm going to film it, record it, and make it into a video. So if you are interested in being one of the first people to support Modarra and buy a bracelet, let me know in the comments down below and DM me on Instagram. I'm very curious. Obviously, these are not going to be cheap. They're not going to be $1,000, but they're not going to be $300. So somewhere in between. Thank you guys so much. Let's start the video. All right, guys, welcome back to Modarra Monday. This is number 10. I'm very excited about that. So we've been doing this for 2.5 months straight without missing a Monday. So I'm very happy with that. I'm also very happy we're over 400 followers on Instagram. Thank you guys for that. If you're not following, go check that out. Link in the description. Today, I said we were going to work on screws, but I have to finish this link saga. I have to nail this, and I think we're really close. I read through all the comments on the last video, and I reply to every single comment, so make sure you guys drop a comment. I love reading them. And we're gonna work on the links. I made these giant 3D printed links to illustrate some different points that I want to show, and I think we have a new process, and we're gonna try it. We're gonna see how it works. And if you guys don't know what we're trying to do here, we are making high-end custom machined bracelets and other wearables. The reason for this is I've been in the machining community for over 10 years at this point. I've seen everyone in the EDC community make knives, pens, all sorts of gadgets and widgets, and I've always loved the idea of melding all these different things that I like. I love machining, I love manufacturing, I love design, I love different materials and patterns and tool paths and stuff like that. But I didn't want to just make a knife, I didn't want to just make a pen, and I wanted to do something different. And so I've literally been thinking about this for 10 years. I'm like, what can I make that's different that I can incorporate all those things in? And so I chose to start this saga off with machined bracelets, and then we'll go into other things. But that's what we're trying to make. We're also trying to build a brand around this. This is for the makers, the thinkers, the designers, the machinists, the people that actually know how stuff is made and appreciate things that we talk about in these videos. For example, I've been spending the last 3 weeks just dialing in chamfers and getting them exactly perfect. So if you're that type of person that loves that type of detail and you understand how tricky these things can be, that's why you wear Modarra, and I'm very excited about this. So guys, I'm gonna go over to a clip of me showing you guys these different 3D prints, and then we're going to go over to Fusion, go through the tool paths, and then let's start making a prototype link. Let's go. All right guys, let's take a look at these large 3D prints here. I made these because I wanted to be able to illustrate some of the edges that we're trying to chamfer and just illustrate this part even better than our previously 3D printed part. And then for reference, this is the actual part size there, so you guys can see the difference. If it hasn't come across on camera this whole series how small these parts are, maybe now you can see that. So with that being said, let's get these out of the way. So this part here, this is our link, and I drew the engraving on there. Actually, let's spin this around here. Let's get this out of the way. Okay, so these are the different edges that we're trying to chamfer. In our previous video, we are orientating the part like this, and the stock is around it like so. And we're basically trying to chamfer everything that we can, deburr everything that we can, but also have reliable tabbing and getting this part to a reasonable op2. I fully understand you could one and done this part on a 5-axis. However, like I've stated before, there's 25 links on this bracelet. There's no way I'm making one of these at a time. Let's say there's 10 tool changes, which I think there might be more than 10 tools to make this link. Let's just say there's 10 tools. That's 250 tool changes just to make the links for the bracelet. Not only is that a time killer, but also that's just not good for a machine if you can avoid that. So ganging them up 10 at a time, we are reducing that significantly. That's just tool changes. Okay, so we've gone from making them 1 at a time to now we're making them 10 at a time. Okay, cool. Now, making them 10 at a time, we have options as far as what kind of material to use. Is it round bar or is it flat bar? We've chosen to go round bar. Why? Well, one, round bar is normally cheaper than rectangle bar, flat bar or square bar. And also, this is one thing that I haven't really mentioned. When I get to the point where I start making these bracelets in exotic materials, I want to make them in exotic materials, and a lot of those materials come in round bar. So that's another thing to consider is future materials. It's a lot easier to get, for example, titanium round bar than it is to get 3/8 square bar titanium. I don't even think that would exist. It would probably have to get cut from plate, which just seems like a nightmare. And same with like Damascus or any of these crazy materials. So that's why we're going with round bar. All right, is everyone with me? We're going away from 1 part at a time to 10 pieces or more, and we are on round bar. All right, cool. So that's why we have made it this far. Next step is part orientation. So as you can see, we were currently holding them up like this. This gets us access to a lot of sides, but it was proving difficult to tab the parts off reliably. And then also, since the tab was, originally I had it in the center of this. That's how I made these. But then I had to hand blend this radius. And this is only 15 thousandths of an inch here. And so any extra blending, you remove too much material, and this becomes way too thin and could break. So I have no interest in hand finishing these, also from a time perspective. Okay, next thing would be we put the tab on this bottom red edge here. So we tabbed off the part, and then our thought was we could flip it and we could just machine this flat, get rid of the tab. Easier said than done. In practice, that didn't work really well. I don't like that process. The other thing in this orientation here is how do I explain this? This radius here is very important. This whole outside shape is very important because that is what you see on the bracelet. And if this will focus. So you really see that blend and that radius there. So that's what's really important to me. And the way we were doing it was kind of a hack way around it, but this way, if we orientate the part like this, we're able to just come around it with a tool, and it's going to be perfect, and it's going to look great. So I'm really happy about that. So, okay, again, we went to this, now we're going to this. And why are we doing that? Well, I made this little model, so this is what it's actually going to look like coming off the machine, more or less. So picture this round bar goes all the way down, 6 inches into our fixture. Technically, this would not be machined, and we'll show the cam here in a second. But what we're able to do with this orientation, yes, it's a lot of wasted material. You can see all of that wasted material. That's fine. But we can do full perimeter of the part, which I mentioned is really important. We can still drill, tap, do all these holes and whatnot in this first setup. And then we could take a key seat cutter and come in here and cut this slot. I don't like key seat cutters for a couple reasons. One, they're really expensive. If you break them, it really sucks. Two, you don't have as much controllability over them as you do with if you can just adapt something and then finish it with contours, etc. And yeah, that's kind of my 2 reasonings for this. And I just don't want to spend $500 on a key seat cutter right now. So that's where we're at. But I thought about this, right? If this is the rod here, the bar stock, and we're going to be ganging these up, right? So we have 10 of them in a row. We can still tip this down with the 5-axis, machine this slot like we were before, just adapted it, then come in here and clean it up just fine. And we can add our engraving, we can deburr all these edges, and we're golden. So the concern was if we did it like this, people were suggesting take a bar like this and do this. Dovetail the bar, that's your op 0, gang these up, key seat, cut them, machine it, flip it, then you're done. Well, that's not actually true because you're not getting the engraving, And then also, I don't like the dovetailing operation because you're adding an op 0. So we're going, this is a 2-op part in my opinion, and I think this is the way we're going to do it. So I don't like making it a 3-op part when we don't have to. So I really think this is going to be the best method. I've said this before with previous methods, but we're learning, we're trying things. So again, maybe I'm not stressing this enough. All of these different chamfers. So we have the red chamfers. I wanted to illustrate that. We have the black chamfers. We have the blue chamfers. In the current setup, the old way, we could not get these black chamfers. We could get the blue ones, and then we also couldn't reliably get the red ones. Now, in this orientation, we're able to get the blue ones just fine. We're able to get the red ones, this one in op 1, this one in op 2. And then the black one was always the last chamfer that I really wanted to get. Simply because if I take this bracelet off and show you guys, I might have to go under the microscope for this, but that edge is right there. This black edge is right there. So you see it, and this is also up against your skin. Now, a lot of these have a lot of different iterations on them. I've been wearing this thing since October of last year. It does not bite, it does not pinch, it does not grab my hair on my skin or anything. It's fine, but I would like to deburr it just because of that. Now, that brings me to another point. I rather prioritize deburring these black chamfers here than the red chamfers. And we'll get into that later, but I much rather deburr these black ones. And so we're able to do that with a key seat cutter in this orientation, and we'll show you guys that in the Fusion. So I just want to make it very clear, this is the thought process of the orientation of the part, the stock, the operations, etc. So hopefully everyone is on the same page with me that's watching, and this all makes sense. So that's where we're at. Let's go ahead and show you guys the Fusion, and then let's go out and try this out. Okay, let's take a look at the part in Fusion in this different orientation that I just showed you guys. So this is obviously our link here, and let's see, do I have, yes, so this is our stock. As you can see, we have orientated our part, I guess hot dog, horizontal, whatever you want to call it. And this is our 1/2-inch stock, so it's a lot larger, a lot of wasted material that I'm not too thrilled about. We might be able to go to flat bar in this orientation, but that's a whole nother conversation. So we've got the part here, and we have our tool path. So I'm going to run through these real quick. So we're facing the top. That's more for stock cleanup than anything. We're going to adaptive. We're going to face the top here to finish that. We're going to rough and finish that. We're going to come down here with a contour. Can you guys see that okay? It might be kind of tough to see. Finish that with a contour with a finishing tool. We're going to bore this hole. We're going to tap that. Then we're going to come in here and adaptive this. Now, actually a few people mentioned that, is what if I drilled and tapped this before I machined out this slot? So we're going to try that and see if that helps with any of those burrs. We might be able to get around not having to deburr these edges. I'm not crossing my fingers on that, but I'm very curious to see how the burrs look if we do it in this order. We're going to finish these walls. Let's come in here. We're going to do the top chamfers, 3D machine. We're going to put our M in the center there. We are drilling that hole. We're chamfering, chamfering, chamfering. Now we're coming in here with a key seat cutter, as you can see, and we're actually going to use this to chamfer these edges. Now, I think I talked about this in the previous clip, but this is going to be a lot nicer than fully using a key seat cutter to cut this slot. Now, let's see, I'm going to assume I mentioned everything in the last clip, but I'm going to repeat myself anyways. Key seat cutters are great. They don't give you as much controllability as obviously machining things with end mills and, et cetera, et cetera. But, and then the other problem is a key seat cutter for something like this, we're talking, at least from Harvey, we're talking $300 to $400, and I just don't want to spend that money on this project right now. I feel like I have all the tools that I need to make this work for now. Yes, once we start selling bracelets, I'm totally okay with optimizing, but as of right now, we're in the negative right now with this project. I'm spending all this time and money on this, and we haven't sold a single thing. So I don't want to skip to a key seat cutter just yet. But I do have a key seat cutter that it can't fully machine this slot. As you can see, the distance from the shaft to the edge of the cutter is not large enough. However, we could use, I thought about this, we could use it just to do a little 5/10 chamfer on these edges. And so I'm really happy about that. And then we tab the thing off. So let's go ahead and simulate this for you guys. So again, I'll speed this up pretty quick. So we're facing, we're going to adaptive this. Let's see, can I turn this up a little bit? There we go. Rough, finish. We're gonna rough this back edge here. Finish that. Okay, we'll finish that. Let's turn off the model here. Let's do this. So we're boring the hole. Tap. We're gonna adaptive this. Finish that. Ball end mill. Add our chamfers. We're gonna do our engraving. Drill this back hole. Chamfer, 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 chamfer. Then you can see here we're just biting away at that chamfer there, and then we're gonna come in here and we're gonna tab this thing off. And we'll figure out if that's a good tab position or if that is too thick, too thin, etc. But now you can see the only thing we have to finish is this back tab here. Face this, because I left some stock on that, and then chamfer, and then we're done. And I think that we could easily just do in, let's get out of this simulation. I think we could easily do that. Let's turn this back on. In soft jaws, something really simple. I think we could easily just finish that backside in soft jaws. So that's what I'm thinking as far as tool paths. Alright, so I spent the last week machining HDPE, so you can see a lot of little bits of plastic. I'll throw in a video before this clip of how dirty this machine is. So I just want you guys to see this looks pretty clean, and then I'll throw in the clip before this of how crazy it was. So I'm thinking for this link, I'm thinking I'm not going to put the whole big tombstone fixture in here. I think because first of all we would have to modify it because those are currently set up for, if I show you guys, so this is currently set up for 3/8, so we would have to drill out these holes to be at least 1/2 inch because now we are moving up to 1/2 inch material here. So what I think I'm going to do, and this is the only piece of 1/2 inch I have, I believe, in 303 stainless, is I'm going to cut this in half, and we're just going to use our collet block in the vise. I think that's going to be the quickest way to test this program out, and if this works and we like it, then we can modify the fixture. But I don't want to do that yet until we test it. So I think that's what I'm going to do here. All right, we actually just sped through this really quickly. But man, it's kind of foggy in here. I'm going to turn on the mist collector real quick. All right. This thing is definitely looking really nice. My Y-axis was off. It's technically supposed to be machined like this, but since we're doing one at a time, it doesn't matter. It's the same process, but we just got to make sure we orientate that. So, yeah, this is looking really crispy, guys. I'm not going to lie. Chamfers look good. I don't know if this is in focus or not. Let's see. Our engraving was definitely not deep enough. That's fine. That's an easy change. Yeah, everything's looking pretty good. The finish is looking pretty good. There's this kind of weird transition line, though, that I am seeing. So I might want to... You guys can actually see it. You see that vertical line right there in the part? Yeah, I don't know what that's all about. But it is buttery smooth, I will say. So now we're coming in here with this tool, and we're going to attempt to deburr those long edges inside the forks there. So we'll do that. We'll take a look at the part. I might adjust the engraving depth, and then we'll part this thing off. But this thing feels really smooth. Like, I'm very happy with that. I think one thing I would change too is we're chamfering the threaded hole here, but there's still a little bit of a burr, so I might actually come back with a finishing tool and just go over the top of that again to knock that burr off. Oh yeah, let's take a look. How's the burr situation looking on the inside? There's definitely still a burr in there, so we'll have to tackle that. But this is just, it feels really smooth. Like, I'm not feeling any sharp edges at all. All right, let's go ahead and try this guy out. All right, this is Sketchville. I can barely hear it cutting. I have it set to 5 thou. All right, and then let's see. We're gonna do one more facing pass on the top here. I ran upstairs and reposted. There's no real reason this needs to be through spindle coolant, but whatever. So this is hopefully to clean up the burr. And now technically we're gonna go to part off, but I wanna take a look at this part real quick. All right, so I don't know if you can see it in there, but the M looks perfect. So that's 3 thou deep. That looks amazing. We definitely, I think that's the move, that there's way less of a burr up top. We'll have to test that a little bit more, but that extra facing pass is easy to do because that's tool 22, and that's the next tool that we're using for part off. So it's not like we're adding a tool change to do that. So I like that a lot. Now, the deburr, this side didn't get anything. The other side got a little bit. It's kind of hard to show. So I think I'm gonna go adjust that tool path and make it 10 thou and rerun it and see what we got. Because we know it'll work, but I think we just need to adjust it, make it a little heavier so it actually shows. But yeah, let's go make that adjustment. I also might add a spring pass for that finishing. I'm really curious about why there's that line that you can see. So I'm gonna do that real quick. Guys, this is looking really good. So I added a spring pass, and now that line got on the outside edge. I don't know if you can even see it, but the finish looks amazing. I'm very happy with that. And we have a deburred edge in there. So yeah, I mean, I think the next step is we're gonna try parting it off. That's the only part left of the tool path that we need to prove out, but you can see we've got a chamfer in there. So I think we're gonna part it off, and we'll probably take a look at it under the microscope. All right. Well, the part didn't fly off. That's the first step. Woohoo! Yeah, that's definitely too thick of a tab, but that's the way to do it right there, guys, because now we got a completely flat face to start machining the next one. Obviously, this is definitely a slitting saw operation in the future because we're basically wasting whatever the diameter of our tool is, which is, in this case, it's 3/16. So we're wasting that much material, which is like half of the length, basically. So definitely slitting saw in the future. So let's measure that. It should be 10 thou, and I'm gonna adjust it, and I'm probably gonna go down to, if that's 10 thou, I'm gonna go down to 5 thou. All right, we've got our part. I just machined some tiny soft jaws for this, and we're gonna try to do an op 2. and we're gonna learn some things, and then we can take this under the microscope. There's a few things that I can see with my naked eye, but I want to point out to you guys under the microscope and be fully transparent. All right, guys, we did it. I ran the toolpath, 1 minute, 17-second cycle time. You guys see that? This looks really good, so I'm going to pop this out and let's go to the microscope and we can take a closer look at it. All right, guys, let's take a look at this link under some serious magnification. Again, this can be dangerous because you see everything under magnification. So, first up, if we get this focused, surface finish on this outside profile is amazing. It even looks good here under magnification. So I'm very happy with orientating the part like this so we can get full peripheral around the part. I really, really like that. Next up would be, what do we want to go over? This top face here, you can see was machined this way. That was my mistake. That will not be the case with the actual program. My Y direction was off. This is the proper orientation that will be machined. So if we focus on that. So again, great surface finish going with the length of the part. Now, we can check out this radius here. You can see this radius looks just amazing. This whole radius just, oh, that's so much cleaner than what we had before. So I'm very happy with that. We can see our chamfers are pretty consistent. That one's a touch larger, but I'm okay with that for now. We still have some weird kind of like mark there. It's on both sides too. I wonder what that is. Just kind of inspecting the part again. We have our chamfers there. Now, let's take a look at the inside here because this is something that we were working on. This is the chamfer that we were talking about. I want to make sure you guys can see that. Yeah, let's turn this brightness up a little bit. So yeah, there you go. You can see that there. It's kind of tough. It's got to hit the light just right for you guys to see it properly. There we go. So now we have a chamfer there, and it looks great. And I'm really happy we were able to figure this out. There is one problem with this. So right there is where this chamfer and this chamfer meets, and it is a sharp corner. It will never be able to not be a sharp corner unless we somehow 3D machine right there. Unless we somehow 3D machine that out. Now, I'm only pointing this out because you could see this in Fusion. You could see that. Actually, here is a really good view of it. This focuses a little bit more. Yeah, right there. You can see that like notch. And again, that's where the two chamfers are attempting to meet, but they will never be able to meet perfectly. Now, again, I'm totally okay with this. I'm just very happy that we're able to chamfer this edge. I just want to point this out that I'm aware of it, and it is something that bothers me, but it is what it is. Now, the one downside, actually this isn't a downside, this is just a mistake. You can see, I think it was more on this side, yeah. You can see those swooshes is from our key seat cutter cutting into this face. So we actually need to reset. You can actually see it there. It's really hard to see in person, but we're going to fix that. That's an easy fix. We're basically going to tell the key seat cutter, stay off that surface by a thou or so, and that way that won't happen. It only happened really on the one side. So we'll make that adjustment. That's not a big deal. Let's take a look at the inside edge of these holes here. Definitely not as bad of a burr. So shout out to the people that mentioned cutting the slot after the hole. That actually might be okay. This back side of the thread, it's kind of tough to tell because of our key seat mishap. We might actually be okay. So I'm going to adjust that link program so this doesn't happen again, and we can pay closer attention. We might not have to deburr these holes, guys. I mean, that's way better than it was before. I mean, you guys remember the nasty burr that had, so that's a huge improvement. The M on the inside, I changed the sizing and kind of width of the letter, it looks way crispier on this one. I'm very happy with this. That looks really good. So I'm very happy with that. And then let's see, what else is there? There is the back chamfers here on this kind of tang, if you will. Now, it's very slight, but you can see it hitting the light there. This chamfer here that goes around. And we have that on both sides because there's the op 1 and op 2. Now, one thing to note on this, again, we're going to have that, we can't get up to that material, so there's a little bit of a straight section there, which is fine. But one thing that I do want to point out is, what was I going to say? Oh, the part itself is again undersized by about 6 thou length, width, height, and I'm pretty sure it's my tool 22, which is the main roughing tool for a lot of this. It just needs to be comped for wear because I measured the tool itself. It's way under. It's like 184 versus 1875. So I think that's where our undersize is coming into play, and that's also making all of these chamfers slightly smaller because the part itself is smaller. So that's something I'm also going to have to start adjusting and paying attention to, is the wear. But overall, I mean, again, we're looking at this under a microscope. This part is looking really nice. Okay, I just want to show myself while I talk. So yeah, I mean, we looked at all the different chamfers of this actual part here. It's looking really good. I think this is, as the Mandalorian says, this is the way, this is the process, I believe, to make these parts. Is first op, change the orientation, stock size gets larger, that's okay. And then we come in here, we're able to machine all these different surfaces, make an op 2. The op 2 is pretty straightforward. It took about a minute, 17 seconds, I think, for the op 2. That'll be a lot quicker. There's only 2 tools, which is nice. It's just tool 22 and then chamfering tool. And I think we can speed that up quite a bit. I think we could easily get that to under a minute per link, easily, especially with the not having to tool change. If we made soft jaws that could hold a handful of these and we could save some time on tool changes, I think we could get this to about a minute per part on op 2 or less. And then, yeah, I mean, we're still shooting for 5 minutes total cycle time on one link. So that's our goal. And again, this thing is looking great. There are a little bit of a surface line there where the jaw was clamping on it. So I'll have to make sure either change the secondary jaw to also aluminum, but also just find a good torque setting that doesn't have that effect. Actually, this is an interesting point. Yeah, so that's only on the steel side of the jaw. So maybe just swapping the jaws to aluminum on both sides would fix that. But also, we don't need to be torquing these down crazy in op 2. The wear of the tool is definitely something that's on my mind because that is changing our part size, and obviously I want to keep that accurate. More for the chamfers than anything. I mean, obviously this part doesn't functionally have to be too accurate. There's a few key tolerances here, but really it's to make the chamfers consistent. And I think we can easily update that. That should be pretty straightforward. So I'm thinking, it's pretty early in the day right now on Sunday. I'm thinking I'm going to call it for the day because this is definitely a victory. And I might start programming the fixture. We're going to modify that fixture. I'm going to have to order some more 1/2-inch stainless. Let's see. I might need to order some more 1/8-inch tools. Oh, we need to order those larger tools for the slot that we mentioned that I had accidentally ordered cobalt ones instead of carbide. So we can do that. Order all that. And I feel like we should be good to go. I mean, we'll have to figure out a better op 2 soft jaw setup. We might just gang them up and do the soft jaws like that. I don't think there's a problem with that. We're obviously, so we're holding them. This is way easier. We're holding it like this in the soft jaws, right? That just logically made the most sense to me. We could hold it like this and cut a cavity like this. I don't like that because of how thin this is. I don't want to crush that. But I'm just thinking we could fit more of them on a jaw. So, I mean, these are what? Less than 1/2 inch wide. So, 6 inches. we could easily fit, I don't know, space them out. So I don't know, we'll have to figure that out. And then also the other concern is if these vary in thickness, obviously soft jaws will only clamp on one part or the other, so that's something I also have to think about here. That's also where I know someone mentioned like Uniforce clamps. That might be a really good idea. Again, these parts are very small, and I've never used a Uniforce actually, so I'd have to play around with those. But this is really close. This is the closest we've ever been, and what's awesome is the finish on this. I think this would be completely fine to not have to finish it. I think if we could keep track of tool life and just keep that finishing tool really crisp, I think this would be okay to ship like this. Straight off the machine. I think these look really good. I still want to play around with potentially tumbling and polishing with a tumbler. That's something I've looked into, but I'm liking how this is turning out, guys. So, okay, now that we know what we need to fix on that link part, I think it's only proper if we add this to our current bracelet. So I'm going to take mine off, and let's replace one of these links with the newly machined one. I'm thinking, let's replace the one right by the clasp here. So I made this other fixture here, and this is a like assembling fixture. So we can slide in a bracelet and easily, it's really more for assembly than disassembly, but actually it works really good because, man, these set screws drive me crazy. Again, this isn't these set screws, I don't know what I'm doing wrong, but these are just not a standard size. There we go. I don't know why it does that. All right. So there's our clasp. That'll be a fun little series there that I don't know if I'm looking forward to that. That's going to be a nightmare. See, look at this. I can't even get this thing out. This is why we're going to flathead, and we're going to be making our own screws. There we go. Jeez. Okay, so we're going to take this link out, and we're going to replace it. So this link is a totally good link. Well, good in the sense that I've been wearing it for almost a year. All right, so we get rid of that. We're going to drop this bad boy in there. So see, that's what's nice about this. And then I can just slide that, and it lines it up. And so I can come in here and I can slide that up. And we can screw this guy down, and it's just lined up. Yeah, this is gonna be nice. Yeah, this is driving me crazy. But, oh, we need one more screw, duh. I can already see, I don't know if you guys can see that, so these links here, so we have the clasp, the new link, these ones here were me playing with radiuses, and you can see how sharp this corner is compared to the radius there. I think this looks way nicer versus having that crazy radius. I think it's a different look for sure, but I think I'm really glad we're going with the kind of more radiused or chamfered look than the radius look. Yeah, these set screws need to be, I can't wait to get to tackle screws too. And it's sticking, the screws sticking out too much, that drives me crazy. But now we have a fresh link. That is the newest part on our bracelet now. And so now I can put this bad boy on. Like so. And now we know that right next to the clasp is our latest link. Yeah, that's sweet. That looks really good. Again, it'll look a little bit better once those chamfers are a little more poppy. Just from the part's undersized, but yeah, that, I love that. I mean, that compared to the radius there, Yeah, no, that's nice. And the finish, I mean, look at the finish. All right, that was a successful video. I know I didn't show a lot of machining, but it is what it is. We have a, where is it? Where's our clasp at? Right there. We have a brand new link installed right there on our bracelet. I'm gonna wear it. I know it's gonna be good, but it's really nice to have a fresh piece on the bracelet because this thing hasn't changed in a while. So this is looking good. I love the way the finish looks. I think we're very close. I'm curious to see what you guys think of this new process in the comments down below. Make sure you guys drop a comment. I read them, I reply to them. Follow the Instagram and let me know down in the comments what you guys think. All right guys, thank you so much for watching. Again, my name's Peyton Dean. This is Modarra Monday.